In this video, we are going to discuss about memory hierarchy. So there are different types of memory, right? One is a processor memory, and inside the processor, I have some memory, right? There's another one is a main memory. Okay, main memory, and another one is uh, secondary memory. Okay, so generally it is of magnetic disk, floppy disk, or uh, USB like that. Okay. So you can see whenever if you consider the size of these three memories, usually the size of this magnetic disk is higher compared to that of the processor resistor. So I can write there is an increase in the size. So the increasing in the size of memory goes in this direction. So which means the magnetic disk size is very higher compared to the main memory and compared to the processor. Main memory size is much higher compared to the processor. So inside the processor I have resistor. Uh, so this is called as processor register. Sorry, and I have a cache. Okay, cache memory. So it is classified into L1, L2, and L3. Okay. So these three are comes inside a processor. So inside a processor, I have a processor registers and cache. Generally, it is of two or more types. So, okay, that is classified as L1, L2, and L3. And so, if you see the speed of the operation, generally the instructions and the data are stored in the processor register. Therefore, this must be higher compared to the processing speed. Okay, the processing speed must be higher, right? This must be in this direction. So if I want to copy any data from the CPU, so it will be slower compared to if I want to transfer the instruction um, uh, from the memory to the from the processor register. So you can see the processing speed must be higher in this direction. Okay, so um, so which memory is helpful for that one means if you see um, if I want to go for higher speed. Okay, if I want to go for higher speed, I have to use SRAM. Okay, SRAM means it is called as static random access memory. But it is um, bulky. Okay, bulky compared to that of compared to DRAM. DRAM means dynamic random access memory. So therefore, whenever I want whenever my focus is on speed, I have to use static RAM. Whenever my focus is on the sizes, then I have to focus on the DRAM. Okay. So since the cache memory and the processes register requires high speed, therefore these two must be of uh, STA, near above STA. Whereas if you see the main memory, this must be of DRAM. So as you know that the floppy disk or magnetic disk is cost very less compared to that of the processor resistor, right? So therefore, if you see the cost per bit, so it will be also in this direction. You see, this magnetic disk is available at reasonable price, right? And they are mostly it is used in the computer system. Nowadays, we are using pen drives, right? Now, but this is very slower compared to that of this types of semiconductor memories. Okay, because the SRAM and DRAM can be constructed with the help of ICs. Okay, that is semiconductor ICs. So therefore, it will be a little bit expensive compared to that of the magnetic disk, but you can this will be faster when compared to these two will be faster compared to the magnetic disk. So you can see my computer is having these three different types of memory unit. So one is processor, and the next one is main memory, and the third one is secondary memory. So here the entire computer memory can be viewed as a hierarchy, right? And I have shown you uh, the fastest access data, the two one, and if you see the processor resistor are at the top in terms of the speed of the access, right? And if you see the cost, magnetic disk secondary memory is low cost, right? So this is called as processor cache. So here this L1 represent primary cache, and the L2 is between this primary cache and main memory cache. So usually I can use only L1 and L2. So if I use only L1 and L2, you can see the L2 is present between the primary cache and the main memory cache. So this is called as L1 represent level 1. So if you see this one, this is somewhat bulky, right? When compared to that of which is processor resistor, right? But it is slower compared to that of processor resistor, right? So this L2 represent L2 cache, level 2 cache. Okay, and in some computers we have L3 level 3 caches, which is of larger size, in addition to that of the L1 and the L2. Okay, so these three are constructed with the help of SRAM technology, and which may be or may not be in the processor that is made on the same chip. Okay, and I have already told you this main memory is of usually of dynamic memory component, right? So if you see the main memory, if I want to, it is very much slower compared to that of cache memory, right? So you can see the bottom of this one is secondary memory magnetic disk, which is of which is operated at a very low speed. So the key to managing this, the operation of the hierarchical memory system, is to bring the instructions and the data that are about to be close to the processor as possible. So this is the main purpose of the cache memory. So we will discuss about the cache memory in the next topic.
Thank you.